Let's talk about functions. Here's the standard. Um, Take a look. Understand that a function is a rule that assigns each input exactly one output. The graph of a function is the set of ordered pairs consisting of an input and a corresponding output. So let's take a look. Let's talk more about this. So here's what a function is. All right, it's a pairing of each number in a given set with exactly one number in another set. Don't worry if you don't understand that right away. We're going to do lots and lots of practice on that. But one of the ideas we need to first talk about here is this idea of input and output. So we don't, and normally in 8th grade, we don't normally talk about this idea of domain, but I'm going to introduce it, might as well, since we're talking about it. There's really sort of four things that all mean the same idea. All right, you have the input, or what's also known as the domain. Okay, the set of numbers that you put into a function. All right, it's really what it is. It's the this is the independent variable. So we can look at that. Okay, the independent variable. It's the thing that I change. It's the thing that I change x, the x coordinates. All right. Then you have the range. The range is the set of all the numbers that come out of the function. The output, the y coordinates, the dependent variable. Okay. Input, output, domain, range. So I know a lot of students will use this in here to remember that it's the input. Okay. Yeah, just vocabulary for there. Okay, so let's go on. It's in the standard as input output, but again, domain and range mean the same thing. All right, so let's do this. I want you to go ahead and identify the domain and range. So first identify the domain for that first one, and then identify the range for the first set of numbers. Go. All right, so hopefully in this first one, you looked at that your domain was 0, 2, 3, and 5, right? It's all the x coordinates, 0, 2, 3, and 5. And then my range would be 1, 2, 7, and 9, okay? And what we're talking about, these are pairings, right? So each of these, this is why the points are together. It's a pair of coordinates, okay? It's the input and output. So when I plug in 0 to this function, 1 is what comes out. If I plug in 2, 2 is what comes out. When I plug in 3, 7 is what comes out. When I plug in 5, 9 is what comes out. Okay, that's the idea. So for each of the inputs, I get an output that comes with it. All right, so go ahead and identify the domain and the range of that second set of numbers there. All right, the domain here is -1, -3, 6, and 4. Again, -1, -3, 6, and 4. It's all the x values. Okay, remember when you plot points, it's x comma y. Okay, so x here, it's x, 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 and x, okay? And then go ahead and identify the range. And hopefully you ended up with 2, -2, 10, and -1. Okay, because that's all of the y values, right? It's here, 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 and here. Okay. Now, let's talk about this idea of a function, all right? Now, I like to use this example. You have a dishwasher, okay? The function of a dishwasher is to do what? Yes, you guessed it, to wash dishes. So when you plug in, right, your input will be dirty dishes. You plug in dirty dishes, and you come out are clean dishes, okay? Dirty dishes go in, clean dishes come out. That's the whole idea. So, and you know it's functioning correctly, functioning properly, okay? So what happens when it's not functioning correctly is something like you put in dirty dishes, right? And you should always get the same thing out. So every time you plug in dirty dishes into your dishwasher, what comes out? You get clean dishes. But let's say one day you plug in dirty dishes and out come penguins, okay? That would be very weird. Who knows? That would no longer be a dishwasher, right? It's not functioning correctly anymore. You might like it. Maybe you'd have a bunch of penguins running around screaming for a fish from you, but it's not functioning, right? Sometimes maybe the next time you plug in dirty dishes and you get out clean dishes. The next time you plug in dirty dishes, you get penguins out. You're not getting the same thing out every time. It is not functioning correctly. That's the general idea here, okay? So let's take a look at what this looks like on a graph, okay? So go ahead. I just want you to practice with this. Just you pick which one, okay, do you think is a function? Okay, so let's look at this. Again, it's the idea of a pairing of numbers, okay? It's a pair of numbers that together Okay, I'm sorry, it's an input always gets one single output. So let's take a look here. If I find it, the x values, if I pick an x value, like let's say I pick here, okay? If I look here, if my pairing here, right? Let's say this is 2, right? So for this, if I plug in 2, what comes out? It looks like maybe positive 2. But what also comes out might be negative 2. So there's 2 different things that come out at the same time, right? If I plug in 2, I might get negative 2, I might get positive 2. So that's not going to work. That would not be a function. And there's this thing that we can use that's called the vertical line test, okay? The vertical line test. And what we can do with this is we can say it helps test for, there we go. It helps test to see, let's go back. It helps us test to see how, if there are more than one output, right? So what I can do here is this allows me, look, if I do this, you can see anywhere on X here, there's 2 values that pop out, okay? So if I plug in this number for X, I could get this, or I could get this, okay? And don't worry, we're gonna practice more with this, okay? So again, I'm gonna look at B here, and as if I put the vertical line here, it fails the vertical line test, right? So it has 2 outputs. For one input, it has 2 outputs. And if I do it here, again, this one has lots and lots and lots of outputs, so this one doesn't work. Okay, if I go here, even though this line is curved, all right, if you notice, anywhere I put this vertical line, it only crosses the other line one time. Okay, that doesn't duplicate. So D would be a function. The rest of them are relations, but not functions. Okay. So let's go ahead, try it again. You try it. Try to find which of these is not a function. All right, so let's go ahead. I'm going to take a vertical line. All right, let's see. Is this one a function? This one looks pretty good. I don't see anywhere where it touches twice. Okay, let's look at A. A, yes, this is not a function. Do you see how it's touching the circle? It touches here and it touches down there. Okay, so not a function. Let's check this one. If I can run this across, it never touches my function or the relation twice. And this one, same, doesn't ever touch it twice. Okay, so A is not a function. B, C, and D are indeed functions. All right, which of these shows a relation that is not a function? Okay, which of these is not a function? Okay, let's do it again. Take this. All right, let's run it across Y. Now, open circle means it's not actually touching it. Okay, so neither one, it actually doesn't touch either one. If it had a solid dot, then this would not be a function, but this one actually is a function here. D passes the vertical line test. It is not. It is a function. C, also a function. It passes the vertical. Nowhere does it touch on the vertical line twice. And hopefully you looked at A and said, oh yeah, I mean this one touches it 4 times, right? Here, 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 and there. All 4 places. Okay, so as long as it hits more than once, it is not a function. All right, which of these is a function? Okay, let's take a look. Not a function, touches twice. Not a function, touches twice. Not a function, touches twice. Looks good, never touches twice. Passes the vertical line test. Okay. Okay, good. So this is a properly functioning dishwasher. This one, if I put in dirty dishes, maybe I get clean dishes, maybe I get penguins. Okay, last one. Go ahead. Which one is a function? Okay, take a look. Let's see. Not a function, touches twice. Not a function, touches twice. This one we did already, right? Not a function. And this one, if you run it across, it never touches twice, so A would be a function. Okay, so now what we're going to do is we're going to talk about actually putting in numbers and seeing what comes out. So we've done this a little bit already, but we're going to use this idea of an input-output table. So again, X are the values. These are the domain, the numbers we plug in. Y is what comes out after we've done whatever operation there is, right? And so in this case, what we're doing is we're putting numbers in and then we're increasing them by 3. So I like to do sort of a 3-tiered number table or input-output table where I do the input, right? This is the input or domain. These are the numbers I plug in, and this is the range. Okay, these are the numbers that come out, and this is the actual function, right? Sometimes people do a function machine, right? Maybe you've seen those before. So let's do this. We're going to take 0, and I'm going to plug it in. So what I'm going to do is I'm just going to rewrite, okay, 0 plus 3. Okay, well, what is 0 plus 3? 3. Okay, what is 1? I'm going to put that in. 1 plus 3. Well, what is 1 plus 3? Well, that's 4. And then 2, plug that in. 2 plus 3. What's that? Well, that's 5. And then 2, put 3 plus 3. Well, what's that? That's 6. And then x is 4. So 4 plus 3. What is that? That's 7. Okay, and that's it. Just putting in a nice simple input-output table. And you can see the pairing, right? So when I plug in 0, I get out 3. When I plug in 1, I get out 4, and so on. All right, why don't you go ahead and try doing this one? Okay, so here's my domain, right? And here's my range, input, output, independent variable, dependent variable, right? This one depends on what x is. And then what are we doing? We're taking the input and we're lowering it by 2. We're subtracting 2. So I'm going to do 0 minus 2. What's that? Negative 2. 1 minus 2. What's that? Negative 1. 2 minus 2. What's that? 0. 3 minus 2. What's that? It's 1. 4 minus 2, what's that? It's 2. Okay, and so here's your pairings: 0, negative 2, 1, negative 1, 2, 0, 3, 1, 4, 2. And then we can put these on a graph. Okay. All right, try that one. Hopefully you had 2x, and we're going to do negative 2 times 0, which is 0, negative 2 times 1, which is negative 2, 2 times, negative 2 times 2 is negative 4, negative 2 times 3 is negative 6. Negative 2 times 4 is negative 8. Okay, so there's my pairing. All right, moving on. Go ahead, try this one. Now, notice in this one, do you see I did 0, 2, 4, 6, and 8. Okay, so I changed my domain. Can you think of why I would have changed my domain? Good. I'm hoping you decided to say, ooh, these are all multiples of 2 because I'm going to divide by 2, right? I want nice whole numbers. So I'm going to take some number and divide it by 2. So 0 divided by 2 is 0. 2 divided by 2 is 1. 4 divided by 2 is 2. 6 divided by 2 is 3. And 8 divided by 2 is 4. Okay? So there's domain. Here are my inputs. Here are my outputs. All right, go ahead, try this one. Okay, hopefully we did 2x minus 2. Now what I'm going to do this time is I'm going to do 2, and I'm going to just, so that I don't forget, I'm going to rewrite this multiple times, and then what I'm going to do is I'm going to just plug in my numbers. Okay, so now I'm going to do 2, 1, 0, negative 1, negative 2. Okay, so let's do 2 times 2 is 4. 4 minus 2 is 2. 2 times 1, 2. 2 minus 2, 0. Okay, 2 times 0, 0. Negative 2. Negative 2 minus 2, negative 4. And you should see, I'm hoping you see the pattern here, right? Negative 4 minus 2, negative 6. Okay, so there are my my pairings, right? When I plug in 2, I get out 2. Now this is a function because every time I plug in 2, I will always get 2 out. Okay? Every time I plug in 1, I will always get 0. There's no way I can not get 0 for this. Okay? But I'm letting you know right now that these are functions already. Don't worry, we'll practice more with it. Okay, so see if you can come up with the rule, or how am I getting from x to y, right? Here's the input, here's the output. What's the rule? Go ahead. All right, so hopefully what you saw is that this is when I plug in 4, right? This goes up 2, up 2, up 2, up 2, up 2, up 2, up 2. So what am I doing? Well, y, the output is equal to the input plus 2. That's it. Okay. Go ahead, try this one. All right, so I'll take a look. 2 to negative 2, that goes down 4, right? I go down 4. 1 to negative 1, that doesn't go down 4. All right, so that doesn't work. So what I'm going to do here is, instead of, if I'm changing, right? So this is going from 2 to negative 2. I tried subtracting or adding a negative. That didn't work. Let's try multiplying. How do I multiply 2 times to negative 2? So 2 to negative 2 would be like multiplying by negative 1, right? 1 times negative 1 is negative 1. 0 times negative 1 is 0. Negative 1 times negative 1 is 1. And negative 2 times 2, right? So what I'm doing here is I'm saying negative 1 times x. Oops, I don't need the parentheses. Let's do negative 1 times x. Or what you could do is say negative x. Okay, and really what I'm doing is each one is sort of the opposite, right? What's the opposite of 2? Negative 2. 1, negative 1. 0, 0. Okay, that's it. All right. Go ahead. Try that one. Okay, hopefully you can see that what I'm doing here is it's half, 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 right? So I'm taking x and dividing it by 2, but I'm also making it negative. So we'll do, there's a couple different ways we could write. We could write negative x over 2. You could do x divided by negative 2, although this one is not typical. If you're going to write it like that, a lot of times what we do is we do negative and then the whole fraction. Okay. All right. No, we're going to skip that one. So there you go. There you have it. Hopefully this made some sense. Please bring any questions to class, and we'll discuss them there.